Uber ride for an air taxi. ABC News has an exclusive look at Joby Aviation's fleet of electric air taxis.
It pressurizes, so it's a big pressure chamber, and then the composite part itself has a vacuum bag on.
Toyota is no stranger to pushing the boundaries of automotive innovation, and its latest leap into the future of transportation is nothing short of paradigm shifting. When one says that a company took to the skies, it is often a metaphorical statement, but Toyota decided it should apply to them literally. Yes, this is no hyperbole or exaggeration. The Toyota CEO has announced that the first prototype of their flying car has shocked the world, and rightfully so. Toyota's venture into aerial mobility promises to disrupt the very notion of how we think about transportation. As they gear up to redefine the skies, one can't help but wonder if Toyota's flying car will become the next game changer for personal mobility. It's a long ride, folks, so gear up and let's get set fly. Toyota takes to the sky. Toyota Motor Corporation and Joby Aviation recently achieved a significant milestone with the successful completion of their first international exhibition flight, hosted at Toyota's Higashi Fuji Technical Center in Shizuoka, Japan. The event unfolded against the scenic backdrop of Mount Fuji and showcased the cutting-edge technology behind Joby's electric air taxi, which boasts an impressively low acoustic footprint and emissions-free design. It is the future of sustainable travel in the air. Imagine a world where air travel is for everyone and you can avoid road rush traffic or long, exhausting land travels. This flight symbolizes the culmination of nearly 7 years of collaboration between Toyota and Joby. Since 2016, Toyota has leveraged its expertise in automotive manufacturing and technology to support Joby's ambitious vision for clean and efficient air transportation. Toyota's engineers worked directly alongside Joby's team in California to make this possible. This partnership deepened in 2023 when Toyota and Joby entered a long-term agreement. Joe Ben Bevert, founder and CEO of Joby, described the flight as a pivotal moment in realizing their shared vision with Toyota. The event brought together prominent figures and stakeholders, including Akio Toyoda, chairman of Toyota Motor Corporation. Joby's electric air taxi is designed to carry a pilot and 4 passengers. The aircraft can reach speeds of up to 200 miles per hour while maintaining 0 operational emissions. Its nearly silent operation makes it a game-changer for high-speed, sustainable travel. Beyond its technological achievements, Joby's air taxi holds immense promise for reducing urban traffic congestion, addressing rural transportation needs, and offering eco-friendly travel solutions. This landmark flight builds upon Joby's history of innovation and extensive testing. Since its founding in 2009, the company has completed thousands of test flights, including high-profile demonstrations at locations like the downtown Manhattan heliport in New York City. Toyota's commitment to this partnership was on full display weeks before the exhibition flight when the company announced an additional $500 million investment in Joby. So, what is Toyota planning to do with all of this? Well, the concept of air travel is nothing new, but making it noiseless and more accessible than ever, especially for everyday use, will be the next big thing in the transport arena. Well, let's dig in and find out what's happening and how it started. The rise of air taxis. The concept of air taxis was first materialized in 1917 with Glenn Curtis's prototype, the autoplane. This early attempt represented a fusion of automobile and aircraft technology, aiming to create a vehicle capable of taking off and landing vertically. Following Curtis's pioneering work, several other inventors sought to refine the concept from the 1920s to the late 1950s. Among them were Henry Ford, Waldo Waterman, and Moulton Moult Taylor. These inventors developed their own prototypes of flying cars. However, these early ventures were marred by technical difficulties, crashes, and a lack of funding. These setbacks hindered the widespread commercial success of such prototypes. From the 1950s to the late 80s, urban air mobility saw some progress, though still far from the modern-day visions of seamless air transport. Helicopters began to play a significant role in providing services in major cities like Los Angeles, San Francisco, and New York. However, the high fuel costs, operational complexities, and safety concerns surrounding helicopter flights made it difficult to scale these services effectively. Helicopter operations also faced challenges with noise pollution, maintenance costs, and an inability to offer efficient short-range flights at affordable prices. Despite these challenges, helicopters served as an early demonstration of the potential for vertical flight in cities. This brings us to the electric vertical takeoff and landing, or eVTOL aircraft. The real turning point for air taxis came in the 2010s, when the concept began to re-emerge as part of a broader focus on on-demand aviation services. The development of smartphone apps, along with advancements in aviation technology, allowed for the booking of helicopter rides for passenger mobility. Companies like Blade, Skyride, and Ubercopter began offering helicopter-based services for urban transportation, with Ubercopter allowing users to book helicopter flights between Manhattan and JFK Airport. NASA and the United States Air Force also launched key programs aimed at improving the safety, scalability, and operational efficiency of urban air mobility systems. These programs laid the groundwork for the future of air taxis, highlighting the technological advancements required to safely integrate electric vertical takeoff and landing, or eVTOL aircraft, into existing airspace systems. At the heart of the modern air taxi market lies the concept of advanced air mobility, or AAM, which refers to air transportation systems powered by advanced technologies such as electric propulsion, vertical takeoff and landing, or VTOL capabilities, and autonomous flight systems. AAM vehicles are designed for short to mid-range on-demand flights, filling a gap between traditional ground transportation and longer-range aviation. The development of eVTOL aircraft, which combine the versatility of helicopters with the efficiency and sustainability of electric propulsion, has become a focal point in this revolution. These eVTOL aircraft promise to be quieter, more efficient, and environmentally friendly compared to traditional rotorcraft, potentially transforming urban transportation and reducing traffic congestion. Today, the air taxi market is positioned at the cusp of a major transformation in global transportation. While significant challenges remain, including the need for regulatory approval, air traffic integration, and infrastructure development, the rapid advancements in eVTOL technology, coupled with increasing investment and government support, are bringing the dream of urban air mobility closer to reality. As we move into the 2020s and beyond, air taxis are poised to become a defining feature of urban landscapes, revolutionizing how we think about travel and mobility in cities. The design of air taxis accommodates a variety of needs, such as passenger capacity, mission types, and operational purposes. The European Union Aviation Safety Agency has also weighed in on air taxi designs, emphasizing the importance of electric aircraft for commercial use. To reduce emissions and enhance sustainability, the agency has proposed that electric propulsion be the predominant power source for air taxis. This aligns with a broader trend toward using clean energy technologies in aviation. Electric aircraft are viewed as the future of air taxi services, offering numerous advantages over traditional combustion-powered aircraft, such as lower operational costs, reduced environmental impact, and quieter operations. Europe's commitment to integrating new electric technology into air taxi designs is vital for ensuring that the industry remains both economically viable and environmentally responsible. Market landscape and regulatory framework. As air taxi designs continue to evolve, several innovative concepts have been introduced to address the diverse needs of the market. One prominent design is the Bell Nexus Air Taxi, which incorporates several types of propellers for VTOL functionality. The quadrature design, with 4 rotating blades, provides stability and maneuverability. Another design utilizes side-by-side helicopter propellers, where 2 propellers are placed on opposite ends of the aircraft to enhance lift and control. The tiltwing design, with 4 propellers that line up horizontally during flight, offers the advantage of efficient aerodynamics during forward flight, while still maintaining the ability to take off and land vertically. These variations in design ensure that air taxis can be adapted for a wide range of uses. A key feature of many air taxis under development is their electric propulsion system, which allows for quieter, more energy-efficient operations, making air taxis an attractive option for urban environments where noise pollution is a significant concern. Companies like Joby Aviation are at the forefront of this technological revolution. Joby has partnered with military organizations to test and refine air taxi designs in real-world scenarios, including cargo transport and medical evacuations. This collaboration allows for rigorous testing in various operational conditions, helping to fine-tune the aircraft's performance and capabilities. The company, partnering with Toyota, is also exploring autonomous capabilities to create fully automated aircraft that can operate without human pilots. This autonomy is expected to be a crucial aspect of the commercial air taxi market, streamlining operations, reducing human error, and enhancing the overall passenger experience. Air taxis are expected to serve both commercial and private markets, providing convenient transportation for individuals and businesses alike. The design and technology behind air taxis will vary depending on the intended purpose. For private use, air taxis may be designed with greater emphasis on comfort, speed, and personal customization, while commercial operations will likely prioritize efficiency, scalability, and autonomy. Autonomous aircraft, which are expected to play a major role in commercial air taxi services, will enable greater operational flexibility and reduced reliance on human pilots, making air taxis more cost-effective and accessible. The widespread adoption of air taxis for urban mobility will depend on a combination of factors, including the development of safe, reliable aircraft, the creation of supporting infrastructure, and regulatory approval. One analysis suggests that airport shuttles and air taxis could reach 55,000 daily trips and 82,000 daily passengers, resulting in an annual market value of approximately $2.5 billion. This forecast suggests a burgeoning market for air taxis, with considerable potential for growth in the coming years. However, the commercial viability of air taxis will depend on the development of appropriate infrastructure, such as vertistops or designated areas where vertical takeoff and landing can occur. These vertistops will need to be strategically located in urban centers and near major transportation hubs, enabling air taxis to operate on demand, much like current ride-hailing services. While this flexibility could greatly enhance the appeal of air taxis, the infrastructure requirements present a significant challenge to profitability. The creation of vertistops and the integration of these landing zones into existing urban environments could pose logistical and regulatory hurdles. Another factor influencing the air taxi market is the long-distance ground transportation trips that typically account for the majority of air taxi demand. Studies predict that 98% of the demand for air taxis will arise from trips that take longer than 30 minutes by ground transportation, making regions with high-density populations of affluent individuals and frequent commuters particularly promising markets. Cities like New York and San Francisco are expected to be among the first to see the widespread adoption of air taxis. However, there are still regulatory constraints that must be addressed. The Federal Aviation Administration currently requires that air taxis be operated with a pilot on board, limiting the scope of operations for autonomous aircraft. It is expected that the scope of air taxi services will expand to include fully autonomous operations. But for now, the current regulatory environment remains a significant constraint on the rapid deployment of autonomous air taxis. The commercial projections for air taxis have become increasingly optimistic, as several companies make significant strides toward bringing air taxis to market. Companies like Uber have been vocal in their belief that air taxis, along with other vertical takeoff and landing aircraft, will revolutionize transportation by providing rapid and reliable options for urban mobility. Uber envisions a future where air taxis are integrated into the transportation grid, offering multi-dimensional routes that are not confined to traditional roadways. To support this vision, Uber plans to develop new skyports located on the top decks of parking structures and existing helipads, which will allow air taxis to take off and land in urban environments. These skyports will enable more flexible and efficient routes for air taxis, which could reduce travel times significantly, especially in congested urban areas. Similarly, eVTOL developer TCAB Tech has raised $20 million in its first round of funding, highlighting investor confidence in the viability of the air taxi market. The company has also received more than 200 provisional orders for its E20 model, which is expected to cost $970,000 per unit. This demand indicates a growing interest in the commercial potential of air taxis, particularly in regions where congestion and long travel times make air taxis an attractive alternative. In addition to TCAB Tech, other companies such as the German consultancy Roland Berger have predicted that by 2025, approximately 3,000 flying taxis could be in operation, with that number potentially rising to 98,000 by 2050. Joby Aviation, the star of today's show, also plans to launch electric air taxi services in New York by 2025. Joby aims to offer air taxi transport from John F. Kennedy Airport to downtown Manhattan. They also plan to offer on-demand bookings, similar to popular rideshare services, which will provide passengers with greater flexibility in choosing when and where to travel. In addition to New York, Joby Aviation is working with Delta Airlines to launch eVTOL flights in both New York and Los Angeles by 2025. However, while the potential for air taxis is vast, several hurdles must be overcome before these aircraft can become a common sight in the skies. Regulatory agencies, including the FAA in the United States and Transport Canada in Canada, are working diligently to ensure the safety and efficiency of such operations. This includes updating air traffic management systems to accommodate the new aircraft, as well as developing certification processes for eVTOL aircraft. At the same time, companies must address technical challenges such as battery life, charging infrastructure, and noise reduction, all of which are critical to the success of air taxis in urban environments. Now, back to our star, Joby Aviation, a success story. Headquartered in Santa Cruz, California, Joby Aviation is a pioneering venture-backed company dedicated to revolutionizing air transportation. With additional offices in San Carlos and Marina, California, as well as in Munich, Germany, Joby represents a global approach to redefining urban and regional mobility. Initially named Joby Aero, Joby Aviation was founded on September 11, 2009, by Joe Ben Bevert in the scenic Santa Cruz Mountains. Leveraging funds from previous successful ventures, Bevert launched Joby as one of several innovative projects incubated on his ranch. The company initially focused on researching and testing key components of electric aviation, such as advanced electric motors, cutting-edge flight software, and lithium-ion battery technologies. Joby's early involvement in NASA projects, including the X-57 Maxwell and LEAP-Tech programs, proved pivotal in its technical evolution. These collaborations provided critical insights and laid the groundwork for its air taxi vision. One of Joby's first public concepts, dubbed the S2, featured an innovative design with 8 tilting propellers on the leading edge of the wing and an additional 4 mounted on its V-shaped tail. By refining this configuration, the company ultimately arrived at its current design, which features 6 rotating propellers optimized for efficiency, safety, and noise reduction. By 2015, Joby had transitioned from conceptual designs to building and testing subscale prototypes of its eVTOL aircraft. These early models validated the feasibility of its unique design. By 2017, the company was successfully flying full-scale unmanned prototypes, and in 2019, it introduced its first prototype. During this period, Joby's growth was bolstered by significant financial backing and strategic collaborations. A Series B funding round in 2018, led by Toyota AI Ventures, raised $100 million, enabling Joby to expand its operations and accelerate development. The company also initiated discussions with the Federal Aviation Administration to lay the groundwork for aircraft certification and announced a partnership with Uber's Elevate division. For its first decade, Joby operated largely in stealth mode, keeping its technological progress shielded from public scrutiny. This secrecy fueled skepticism, with some doubting the feasibility of its ambitious claims. A turning point came in 2018 when select journalists were granted access to its aircraft under strict confidentiality agreements. In January 2020, Joby emerged into the public eye with a groundbreaking $590 million funding round led by Toyota Motor Corporation. This milestone marked the beginning of a new era for the company. Alongside the funding announcement, Joby unveiled its production-ready eVTOL aircraft to the world. Joby's production eVTOL aircraft represents a breakthrough in sustainable transportation. Capable of carrying a pilot and 4 passengers, it combines speed, efficiency, and environmental consciousness. The aircraft can reach speeds of up to 200 miles per hour while producing 0 operational emissions and operating at a noise level far below that of conventional helicopters. This design is tailored to address urban congestion, provide accessible transportation in rural areas, and minimize environmental impact. Joby has also strategically aligned itself with key players in both the aviation and automotive industries. Toyota's deep involvement as a lead investor and manufacturing partner exemplifies the cross-industry collaboration required to bring eVTOL technology to market. With a total of $894 million invested by Toyota, Joby has secured the resources and expertise needed to navigate regulatory challenges, achieve certification, and scale production. Joby aims to redefine how people perceive distance and connectivity. As it continues to develop its air taxi service, the company is poised to play a central role in shaping the future of mobility, offering an eco-friendly alternative to traditional modes of transportation while paving the way for the widespread adoption of electric aviation. In January 2020, Joby announced its intentions to construct a state-of-the-art manufacturing facility at Marina Municipal Airport in California. This development was pivotal, signaling Joby's transition from prototype development to scaled manufacturing. By the end of 2020, the company had acquired Uber Elevate, integrating Uber's air mobility division into its operations to strengthen its market position. Around the same time, Joby earned the US Air Force's eVTOL airworthiness certification under the Agility Prime program. The momentum continued into 2021 with a strategic partnership with Garmin, which would supply advanced flight deck equipment for Joby's eVTOL aircraft. Joby also achieved a critical milestone by securing the FAA's G1 certification basis for its aircraft. Following approval from the City of Marina and the FAA in June, the company's production facility plans were set into motion. By August, Joby achieved a 155-mile flight on a single charge. Joby went public on August 11, 2021, through a merger with a special purpose acquisition company. This success, however, was tempered by challenges, including a February 2022 test flight crash caused by an in-flight component failure, which the National Transportation Safety Board attributed to structural issues. Despite this setback, Joby continued to innovate, acquiring hydrogen aviation pioneer H2Fly in April 2022. This acquisition laid the groundwork for hydrogen electric propulsion advancements. By May 2022, Joby had received Part 135 air service certification from the FAA, allowing it to operate a fleet of Cirrus SR-22 aircraft while preparing for the eventual certification of its eVTOL aircraft. The culmination of years of research and development came to fruition on June 28, 2023, when Joby unveiled the first production version of its eVTOL. This milestone included FAA approval for flight testing and a significant $131 million contract with the US Air Force. This became the first eVTOL delivered to a paying customer. Joby also showcased its technological prowess in urban settings, with its eVTOL performing a demonstration flight at the downtown Manhattan heliport on November 12, 2023. This marked the first eVTOL flight in New York City. During the International Civil Aviation Organization's first Advanced Air Mobility Summit, Joby announced its intention to become a certified air taxi operator in the UAE in February 2024. The same year, Joby acquired the autonomy division of X-Wing, bolstering its capabilities in autonomous flight technology. A remarkable achievement in sustainability came on June 24, 2024, when Joby's S4 eVTOL demonstrator, retrofitted with a hydrogen electric propulsion system, completed a record-breaking 523-mile non-stop flight. Powered by H2Fly's advanced hydrogen fuel cell system, the aircraft emitted only water vapor during the flight. So, why is Toyota interested? Well, it's simple. The Joby Air Taxi is a promising investment. It has been designed to redefine transportation with its sleek, electric-powered capabilities. This 4-passenger aircraft, piloted by a single operator, is engineered for optimal performance, offering a maximum range of 150 miles or 240 kilometers on a single charge and achieving top speeds of 200 miles per hour or 320 kilometers per hour. It can handle a maximum payload of 1,000 pounds, making it versatile for passenger and light cargo transport. The aircraft's hybrid functionality allows it to take off and land vertically like a helicopter, while seamlessly transitioning to a horizontal cruise like a fixed-wing plane. This dual capability ensures operational efficiency in dense urban environments where space is limited. What sets the Joby Air Taxi apart is its near-silent operation. The aircraft is 100 times quieter during takeoff and landing than traditional helicopters. Additionally, its fully electric propulsion system eliminates emissions, aligning with global sustainability goals. Joby plans to mass-produce the eVTOL aircraft and operate it as part of a piloted on-demand air taxi service, offering per-trip passenger pricing to make the service accessible and competitive with ground transportation options. The 2020 acquisition of Uber Elevate was a strategic move by Joby Aviation to accelerate its entry into the commercial market. While Ubercopter relied on Bell 430 helicopters operated by a third-party company, Elevate provided critical software tools for market selection, demand simulation, and operational logistics. Joby's international collaborations have further demonstrated its commitment to advancing urban air mobility. As noted earlier, in November 2024, a historic test flight in Japan, conducted in partnership with Toyota, showcased the viability of air taxis in densely populated urban landscapes. This flight emphasized Toyota's dedication to expanding its focus on sustainable, electric-powered transportation beyond traditional automotive technologies. Similarly, in December 2024, Joby marked another milestone by becoming the first company to participate in Korea's KUAM Grand Challenge. With its focus on safety, sustainability, and cutting-edge innovation, the Joby Air Taxi is poised to transform urban transportation. Now, let's see how Toyota fits into the equation. Toyota's bet for dominating the future of automobiles. Toyota's vision for dominating the future of automobiles rests on a strategic blend of innovation, sustainability, and technological foresight, which is evident in their ongoing development of electric vehicles or EVs, hydrogen fuel cell vehicles or FCVs, hybrid technologies, and eVTOL aircraft, as we just saw. While many of Toyota's competitors, such as Tesla, focus solely on electric vehicles, Toyota is taking a more diversified approach, believing that multiple types of electrified powertrains will coexist. This multi-pronged strategy includes hybrids, plug-in hybrids, fully electric vehicles, and hydrogen-powered vehicles. This way, Toyota aims to mitigate the risks associated with relying solely on one type of technology, as well as addressing different market needs, consumer preferences, and regional energy policies. One of Toyota's key pillars for future growth is the development of both electric and hydrogen vehicles, with the understanding that these two technologies can complement one another in the race for zero-emissions transportation. The company is betting heavily on hydrogen as a viable alternative to battery-powered EVs, especially for markets where longer-range vehicles are needed and where hydrogen infrastructure can be developed. In 2021, Toyota announced its ambitious plan to invest $70 billion in the development of EVs and batteries over the next decade. By 2030, the company aims to have at least 15 all-electric vehicles in its lineup and to sell around 3.5 million electric cars annually by 2030. This is a substantial leap from its current EV sales, which accounted for just 160,000 units in 2020. Toyota's first major entry into the fully electric vehicle market is the Toyota bZ4X, which debuted in 2022. The bZ4X is a compact electric crossover SUV. The vehicle is part of Toyota's broader BZ or Beyond Zero lineup, a series of all-electric models that Toyota plans to expand over the next few years. The bZ4X offers an estimated range of 250 miles on a single charge and incorporates advanced safety features such as adaptive cruise control, lane keeping assist, and automatic emergency braking. Toyota has also been a pioneer in hydrogen fuel cell technology. The Mirai, which was first introduced in 2014, remains one of the few hydrogen-powered vehicles on the market. As a result, Toyota's bet on hydrogen fuel cells, or FCVs, has been met with both optimism and skepticism, as hydrogen infrastructure remains underdeveloped in many regions. The Toyota Mirai is powered by a fuel cell stack that combines hydrogen with oxygen from the air to produce electricity to power the vehicle. In contrast to battery electric vehicles, which rely on electric charging infrastructure, fuel cell vehicles require hydrogen fueling stations to operate. Currently, hydrogen fueling stations are concentrated in specific regions, such as California, Japan, and parts of Europe, making hydrogen-powered vehicles a limited option for consumers in regions without a robust hydrogen infrastructure. Nonetheless, Toyota is committed to expanding hydrogen-powered mobility, not only in the passenger vehicle segment, but also in commercial and industrial applications. For example, Toyota is developing hydrogen-powered trucks in collaboration with other companies, including the Toyota Project Portal, a hydrogen-powered big rig truck. The company's vision for hydrogen extends beyond passenger cars to various sectors, including the maritime, rail, and aviation industries, where hydrogen could offer a sustainable alternative to fossil fuels. By 2030, Toyota aims to sell 200,000 fuel cell vehicles annually. The company's efforts to expand hydrogen infrastructure, such as the development of hydrogen production technologies and fuel cell systems, indicate that the company views hydrogen as a key element in its future success. However, the competition is fierce. Tesla, the dominant player in the EV market, has become a key benchmark for Toyota and other traditional automakers. Tesla's focus on producing long-range, high-performance EVs, along with its superior battery technology and massive supercharger network, has given it a significant lead in the market. In response, Toyota is accelerating its EV production plans, but the pace at which it can ramp up production remains a critical question. Other major automakers, such as Volkswagen, General Motors, Ford, and BMW, have also committed to electrifying their fleets, with many planning to phase out internal combustion engines entirely by 2035 or 2040. Volkswagen in particular is ramping up its EV production, while GM has committed to becoming a fully electric company by 2035. Naturally, Toyota is leaving no page unturned. How best to beat one's competitors when they're innovating just as rapidly as one, and perhaps even faster in some areas? One can pick an area that has gone more or less untouched by others. Investing in eVTOL technology through Joby Aviation provides Toyota with a strategic advantage by positioning the company at the forefront of the rapidly evolving urban air mobility market. With its multi-million-dollar stake in Joby and active collaboration on manufacturing and design, Toyota not only diversifies its portfolio, but also gains a foothold in an industry projected to reach a valuation of $1.5 trillion by 2040. By leveraging its expertise in automotive manufacturing and supply chain efficiency, Toyota supports the development of Joby's eVTOL aircraft. This partnership allows Toyota to remain competitive against rivals like General Motors and Hyundai. By integrating eVTOL advancements with its broader innovation strategies, Toyota can become the leader of the next wave in transportation. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.